Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials or any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com. Thank you.
Kubernetes, a tool which I'm going to teach you right now, is one of the most popular tool in the world of container. But for what? We will discuss anyways. But one of the most high demanding skills any software engineers can have it is Kubernetes. If you are a dev, you need Kubernetes. If you are a QA, you need Kubernetes. You are a manager, support, operations, whatever the kind of roles you are performing right now in your project, you need Kubernetes. Without Kubernetes, you cannot run any application in the dev environment, QA environment, pre-production and production. You need Kubernetes. Now, this is what we are going to cover in the next 2+ days. So guys, we say Kubernetes will bring health, wealth, and happiness. Health for what? Whom? For the employee. We are the employee, right? So health for us. But how come? We will get into that. But wealth for organization and happiness for both of us. So the question is how this Kubernetes can bring health and wealth and happiness, everything together. So if you really want to know how can it be possible, you need to know what is Kubernetes. What is Kubernetes? What is a Kubernetes architecture? You need to install Kubernetes and working with the pod and deployment and many more. So same thing I'm going to start with. I'm going to teach you what is Kubernetes and what is a Kubernetes architecture right now. Okay, so let's get started. What is Kubernetes? So if you want to understand what is Kubernetes, you have to answer these 4 questions. Where did it come from? What does the name mean? What does it do? Why do we have it? So guys, Kubernetes is born in Google. Yes. And Kubernetes got donated to CNCF in 2014 as part of open source initiative. Now, those who have no idea about what is CNCF, please go to their website and wiki and find out what is CNCF. It's one of the largest organization which govern the largest set of open source project, and the valuation is if I'm not wrong, the valuations people say is still in trillions of dollars. So that's a value of CNCF. Now this Kubernetes is written in Golang. Yes, Kubernetes is written in Golang. Their source code is freely available at the github.com. Their website is kubernetes.io. Slack channels, meetups, groups are there. So now where did it come from? So guys, we believe the Kubernetes DNA is matching with Bog and Omega. Now what is a Bog and what is Omega? We will only talk about it, but we don't know all the features of Bog and Omega, because Bog and Omega is a proprietary tool on which Google infrastructure runs. Whatever the applications you are consuming right now, you don't know whether it's maybe running on Bog and Omega, the application which is highly scalable, highly available, highly very good speed and everything, you get it, right? It's not down for even a milliseconds. And that kind of infrastructure, that kind of application is running on Borg and Omega, which is proprietary tool for the Google. So we believe, we are not saying it's an evolution of Borg and Omega, but we believe the DNA is matching. Why? Because Kubernetes also can do something similar, something similar. So Kubernetes, you can run your application in data center with each. So Kubernetes is open source. So what's the name? What is the definition of the meaning of the name of Kubernetes? So guys, this has been taken from the Greek word, and that is called helmsman. What is the definition of helmsman? So the person who steer a ship. Let me tell you here, no matter whether the ship size of fishing boat, or maybe aircraft carrier, or maybe largest petroleum vessels, maybe is of 600 meters or 700 meters in size. What is the size? Irrespective of that, the ship is managed, handled by one person. Yes, and that we call in Greek helmsman. So same way, guys, no matter your application runtime infrastructure, a data center, which is of a consist of one machine or 1,000 or 10,000, Kubernetes will manage it. Kubernetes can handle it alone. So that's the definition of Kubernetes. In short, we call it KATS. So overall, yes, he's born in Google, donated to CNCF in 2014, open source Apache 2.0 license. First release has happened in July 2015. Golang source code you can find out, and rest of the information. So guys, did you understand what is Kubernetes? Any questions so far? Any questions so far? So now the question is, we should know why. Fine, I got to know Kubernetes. What is Kubernetes? But why we are using it? Why we are learning? Why we are learning Kubernetes? Because without some justification, we don't want to spend our whole day, remaining 2 days. Why we are learning it? And we are learning Kubernetes. We are learning Kubernetes because of two statements. These are the two statements. Guys, we have spent a lot of time on the container technologies like a Docker Compose and all. We spend each and everything we covered actually in terms of Docker. We covered Docker images, we covered Docker volume, we covered the Docker networking, we work with the containers, everything we did it. We understand the architecture also, how it works, what is a container, everything we did it. But guys, it has a problem. It has a problem in terms of scalability. So containers bring scalability challenges. And second statement is, we are starting to view the data center as a computer. So how both are relevant in terms of answering a questions of why we need Kubernetes. So let's understand this. So I think I would like to put some pictures here so you can visualize this. Okay, you can visualize this. Now guys, here right now there's one host. Think about it. It's a very simple problem. There's one host. I've got installed Docker. Now this Docker can manage one container, two container, and three container. That's the maximum capacity you can have, the number of containers in that particular host. Now the question is, if I want to run that container technology in the data center, so of course I am not going to run 3 containers. I am going to run 300 containers or 30 or 3000 containers, right? So what we will do, of course, you'll think, okay, no problem, get more host, one more host, get more Docker, get more containers running. Get more containers running by this Docker. Remember, Docker is a container management tool. But have you realized that in a data center, you have hundreds of machines? That means hundreds of Docker engine. That means each engine is managing their own containers. So now the question is, who will manage multiple Docker? Because Docker cannot manage another Docker. We need some tools to manage Docker at the multiple host. So Docker can create a container. So that's what we said. Containers technology bring the challenges with scalability. You want to scale this from one host to 2 or 20 or 200, you will find the challenges because you need a management tool to manage all this Docker across the host. But are we having it? Docker is not having that feature. So what should we do? We have to find out the new tool for it, because that container we want to run in data center also, because it gives lots of features. Correct? So guys, this is one of the statement. So why we say that containers bring scalability challenges. So now one more problem, guys. You know container very well. So here, what we have is, now if you're running a container technology in the data center, so load balancer need to access, let's say all these containers are Apache, so this load balancer need to access all these container. Think about it. Now, do you think load balancer will be able to add a container directly? You must be thinking, okay, no, you'll not be able to access directly. But what you can do, you can expose this container to the host. So guys, you forgot that we can expose to 80, but this container has to be exposed to 81. Do you think this container and this container both can be load balanced by load balancer, because it requires a similar port, which is not possible because the host machine you have on network. So guys, we need something different solution. Think about it. So load balancer can access all the container. Docker is not having right now that feature. So we need networking solutions also. See here, we need one solutions where we can run the container at the multiple host. We need another solution where the container can be accessible to the load balancer. Because if you are not able to load balance the container, how it can be accessible from outside? But guys, there's one more problem here. And the problem here is, let's say in your data center, the node get disappeared. So right now it has a 3 container. It got disappeared as well. So we need an intelligent tool. Let's say if the node get disappear, that this 3 container should be created. If this space is here, then it should be created here, or you should add automatically should add the new host and it should be creating here. So are we having that intelligent in place where the tool will check, okay, I want to run X number of containers in my data center, and at any given point of time, it should be running that many containers only. I'm not going to call L1, L2, L3. I'm not going to call my employees in a midnight, 2 o'clock and 3 o'clock stating that production is down. Health issues, right? So guys, did you understand the problem with the containers bring scalability challenges? Are you all okay with it? Now, did you understand the problem with the Docker and containers? All of you?
Yes.
Guys, second statement is also very important. And the second statement is, we are starting to view the data center as one computer. What does that mean? So let's understand this. So here, Guys, here what happens, think about it. You are having one host powered by one CPU, two CPU, three CPU, powered by multiple RAM, one RAM, two RAM, three RAM. But when it comes for the compute unit for the Docker view entire compute unit, entire storage as a one unit. No matter how many CPU and how many RAM you added, Docker view entire compute unit as a one unit. So understand that you are running container in the data center, which we have a multiple host. So guys, same way, the way Docker looks all the CPU and RAM as a one compute unit, same way, if you have a multiple Docker host, this particular tool should look this whole compute and whole RAM as a one compute unit. It should believe it is one compute unit. So who can do that? So guys, these are the two statements we need to solve, and solution is Kubernetes. So Kubernetes can manage it. Kubernetes is a solution for running containers in your data center. Kubernetes is a solution for running container at the large scale. Kubernetes is a solution for making sure that number of containers should be always up and running. Kubernetes is responsible for to make sure the containers placement in the right host by looking entire data center as a one computer. So why we need Kubernetes? At least you get a glance of it. But same time, guys, you have to change your mindset. Yes, it's all about the pets versus cattle. Let me tell you here, from last 3 days, you were having a mindset of like a owner of pets, not owner of cattle. So how is different? See here, pets, something goes wrong, you take them to doctor, you feed them, you love them, you go, you walk with them, we walk around them. So all this thing you do that, right? So same thing you did from last 3 days with the containers also. You troubleshoot the container, you created a container, you got inside a container, you come out of the container, you did everything what you could do with the container. All the commands of Docker we have covered. But guys, you have to come out of that mode, because you are not pet owner anymore. You are not playing with the container in one host anymore. You are managing an entire data center. That means look at the cattle mindset, businessman mindset. Let's say if you are the owner of the cattle and you are supposed to deliver 100 liters of milk to the client every day, and let's say some of the cattle are not responding well because of some problem with the cattle, so you're not going to create excuses of with your client saying that, okay, clients, please wait, my cattle is not working, let me fix it, and then I will deliver the 100 liters of milk. By that time, you please manage with 80 liters of milk only. Would you say that? Your client will leave you alone. You will be out of your business soon. You cannot say that. So what you will do, you will replace the cattle who's not performing well with the cattle who's performing well and can deliver 100 liters of milk every day. 100 liters of milk means 100 liters of milk has to be delivered. So you will not get associated or hampered by the cattle's unavailability. You are focused on the 100 liters of milk. So this is a kind of mindset you have to change, guys. You are in operations. Your only concern is to run 100 containers or 1000 containers or 10,000 containers in a data center. If some of the containers are not running, It should automatically get replaced. Not you all will also do the something. Tool should do that something. So if let's say you are running 1000 containers in a data center, out of that 100 got stopped because of certain reason like hardware, software, network, this, that, any reason, automatically those remaining 100 containers should be created with the available infrastructure which you have, and 1000 means 1000 in a production. So that kind of mindset you also need to bring in order to learn the Kubernetes. So it's all about the pets versus cattle. So guys, what is Kubernetes? Guys, Kubernetes is a container orchestrator. Yes, when you say orchestrator, that means using the Kubernetes, we can run the container in your data center, orchestrate the container at the large scale. Yes, Kubernetes can do the work placement also. Mind it, I said Kubernetes, I mean, with the help of the Kubernetes, you can view entire data center as one computer. So Kubernetes have this capability to place work. Place work means to run container in a certain nodes where the resources are available. Yes, that is called workload placement. That you will not do that. Kubernetes will do that. And same time, infrastructure abstraction. That means whatever the complexity of the infrastructure which you have to accomplish this thing, you will not experience that. Kubernetes with it, he has all this in place. And same time, Kubernetes is also helping you to manage the desired state. Desired state means if I want to run in my data center 100 containers at any given point of time, it should be 100 containers, not 99, not 101. It should be the same. So guys, this is Kubernetes. This is Kubernetes. Did you understand that now, guys? Great. So guys, what is the benefit of Kubernetes? So benefit of the Kubernetes is speed of deployment. I think you have already experienced the containers, how much time it takes to create it. So if you want to deploy your application to hundreds of machines, just a matter of few seconds. That's all, nothing else. It has a benefit of ability to observe changes quickly. What is the meaning of it? Let's say you have a patches v1, v2, v3, v4. So you want to upgrade your entire data center in one go within a second. I said second, not a days, not hours. So can you do with the Kubernetes? Yes, you can do that. Ability to recover quickly. So let's say you deploy something and that deployment went wrong because of some bugs in the software. You want to recover, roll back actually. So can you do that rollback in 1 second without impacting anything else? Yes. With the help of Kubernetes, you can do that. And same time, hide complexity in the cluster. That means whatever the complexity you have, it's there in the cluster. You don't have to experience it. It's just one doing wonderful job on behalf of you, and it's just doing the work. Nothing is not bothering you to ask anything. So this is the benefit of Kubernetes. With that, guys, Kubernetes is moving fast. So the best way to be in line with this technology is to be practicing almost every day, every week, and stuff like that. So with that, we should know how this Kubernetes works. So we understand what is Kubernetes. Then we understand why do we need Kubernetes. Then we should understand how Kubernetes works. What is the architecture of the Kubernetes? So we all are spending our time with it. So let's get into the architecture. So guys, before that, getting into the architecture, we must understand the big picture a Kubernetes can help you with. So Kubernetes is an orchestrator for microservice app. So in the last slide, we learned Kubernetes is a container orchestrator, but now we all are learning orchestrator for microservice as well. Now guys, what is a microservices? I'm not getting into that microservices concept too much, but at a high level, let me tell you here. Initially, we had a monolithic, then we got SOA, service oriented architecture, and then now we are using microservices. So in the world of microservices, we have microservices like 100, 200. Remember, one microservice is like one feature it give you, and that may be running in 10, 20, 30, 40 machines. That's a different case, but it's a one microservices, one endpoint. So like that, you will have in your product hundreds of microservices. Some of them are front end, some of them are back end, some of them are business logic. Correct? So a question is, who will manage so many microservices? I'm not going to manage, you are not going to manage. There are some tools required to be used to managing that, and that job also can be done by the Kubernetes. That's the reason we say Kubernetes is an orchestrator for microservice app as well. How? Let's understand that. So guys, this is a football field which we have here. This is the football field. And now we have a manager and team. Now guys, what should be the objective of that each team player? What should be the objective? And if you're thinking, okay, the objective of the each player is to make a goal, then you are wrong. You are wrong. Because if each team player is setting the objectives to make a goal, they will be near to goal post, and everyone will try to do the goal. And this is how you used to play in our childhood, right? We used to be near to the goal post and saying that, shouting at each other, saying that, give me the ball, I'll make a goal. But guys, that is not objective, because this is how you're not going to play the game. You're not going to win the game. So what should be the objective? What is the objective? So guys, teams are not having objective is to make a goal. That is where, if the chaos is being created, that is where the manager is coming into the picture, coach is coming in the picture. And manager knows, coach knows, master knows each and every player's capability. Someone is very good in attack, someone is very good in defense, someone is very good in coordination, someone is very good in terms of saving a goal. So manager understand each and every capabilities and then instruct. Listen, if you want to be on ground, you do follow me. You do what I say. If you do not obey me, I will throw you out of the field. And that is where each player is playing with the coordination. So now what is the objective for the team? So guys, the objective for the team is to just pass the ball. Do not run. Do not try to make a goal. Just keep passing the ball, because if you run too much, you will get tired. But ball can run faster than you, and ball never get tired. So if you can pass the ball efficiently, and if you have a better coordination in terms of the passing the ball, so there are two players who's playing front end who will address all the stuff. Strikers are striking into the goal post. So here, how come this discipline has come in the team? Because of manager, because of coach, because of master. So guys, now look at the world of microservices. In the world of microservices, you don't have 1 or 2 or 20 microservices, you have 100 of each.
To get our channel membership, click onto the join button, select the 3D99 plan and grow your skills immensely.
Now the question is, 100 of which, what is the goal for each microservices? Who will manage their coordinations, control, request and response? The microservices could be HTTP server, search, auth, database, KB stores, log, this, that, and all stuff like that. So we'll manage it. So all these microservices will be managed by Kubernetes. That's the reason we call it Kubernetes is an orchestrator for microservices as well. I'll show you that. It's very easy to do that in Kubernetes, by the way. Very easy to do that. I'll show you. So guys, now Kubernetes define who should be talking to which one. So you see here, there is a microservices of HTTPS, load balancer, auth search, and this, that, and all. And you see all the communication of request and response is been managed by Kubernetes. And this is a good picture. You see that these microservices like HTTPS, look at it, is running across the node actually. One is in node 1 and another one is in node 2. So this is the beauty about it. So that's the reason we call it Kubernetes is an orchestrator for microservices as well. And the microservices, the one of, let's say, HTTPS microservices, which may be running in the across the node, but the behavior is still same. That's a wonderful thing what you have. So with that, guys, let's get into the architecture of Kubernetes. So guys, in the Kubernetes, we have cluster. We always say there's a cluster because it's all about the operations, guys. It's all about the production. And let me tell you here one more thing. It's not like that if when I say operations, then you will, if you're in a dev team, you cannot set up the cluster because ultimately you have to test your application in the cluster also. It may be a cluster of 1 node or 1,000 nodes. Behavior will remain same, by the way. So guys, in the Kubernetes cluster, we have two major component, master node, worker node. The node one which you see here is a worker node and the master node also. So master node, it can be multiple, node also it can be multiple. Remember, master is something acting like a manager, like a coach, like a mentor, like a master. Okay, who manages every nodes actually, or entire clusters, by the way. And who manages the master? Look at this, some packages which we deploy from outside and that we manages. So guys, we have a cluster contains master node, master's node. And who's controlling master? Master manages the node and deployment packages manages the master, and we write the deployment packages. So our job is nothing but to write a deployment packages. We'll deep dive into this slowly. And you see here in this image, it's very interesting image, guys. So we got to know in the Kubernetes cluster, we have a master and we have a worker, we have a node. The node has a pod. Yes. What is a pod? I don't know. But I see that in the image, node, we have pod. And a pod, we have container, the container things which I know very well. We know very well, right? But what is pod? I don't know. But one thing I know that for sure is node has a pod and pod has a container. That means if someone will ask me at this stage, what is a pod? So I would say node has a pod and pod has a container. But still, what is a pod? I don't know. We will find out together. Okay, so here, let's deep dive into masters. Let's deep dive into masters. So guys, master, we also call it in the documents, Kubernetes documents, when you read it, they will mention control plane. Okay, so control plane. Sometimes they refer masters also. It's up to you. Either you call it master or control plane, it's up to you. Okay, both are same. So guys, master manages the node. So guys, node master is in Linux and 64-bit. of the Kubernetes. Node also is in Linux 64-bit, any flavor of Linux. But you know one thing, Windows 2019 onwards, you can have a node of Windows as well. Yes. So Windows, Microsoft support Windows for the Kubernetes as well, but the operating system has to be 2019 plus. So yes, node can be in Windows and Linux. These slides need to be updated, by the way, with the Windows also. So guys, master have 4 components. I'm talking about masters alone. Remember, master can be multiple masters also, because it's, see, master manages entire cluster. And if the master goes wrong, master is down, so what will happen to the entire cluster, entire runtime applications? Everything will be down, right? And that should not happen. So yes, for the master, there are 3 masters, can be 5 masters, can be 7 masters, can be possible. But yeah, 3 masters is more than enough. So yes, master can be a multiple masters as well, and that is, we call it multi-master HA, high availability. And each master will have a same components. Again, we will discuss this one in later point of the time. How can we set up a multi-master cluster? Guys, here I see that in this image, master has a 4 component. Master manages the node. Node can be of Windows and Linux, 64-bit 2019 plus for Windows. But node has a pod and pod has a container. But guys, here I should notice something else also. Guys, if I look at it very carefully, please mind it here. I see that master manages the node and node has a pod and pod has 2 containers. That means a pod may have a multiple containers, or pod may have a container, 1 container. Here in the second image, second side of the image, I see node may have a multiple pod. So see that very simple thing, guys. Master have 4 components. Master manages the node. Node have a pod. Node may have a multiple pod. Node may have a pod which may have a 1 container or multiple container. See that beauty of this. What is a pod? I don't know. I got to know, and that is what is container. But still, I get some idea about it. If you want to deploy a pod through Kubernetes, sorry. If you want to deploy the container through the Kubernetes, you have to keep in pod. But what is a pod? I don't know. But you have to keep in pod. But what is a pod? So guys, I got to know pod is inside a node. You may have a multiple pod in the node. You may have a multiple container in the pod. That I know for sure. So guys, are you okay with this image? So guys, let's focus on the 4 important component of master. Are we ready for it? Can you please say yes or no for any questions, any doubts, guys? Okay, so guys, the first component, we call it API server. What is API server? Please read it. It says front end to the control plane. Control plane means Akka master, okay? So it's a front end to the control plane. And the control plane which manages the entire cluster, mind it here. Also, it's getting exposed the API, REST API, and then same time consume JSON. Always remember, API I have seen like most not, I've not come across any other APIs which is not consuming JSON, because maybe I need to upgrade my skills. But most of the APIs which I have used throughout my career, they have consumed the JSON only. So they may be having different protocol. I mean the different type of data. I don't know, but right now most of the API server API is consuming this one only. So yes, this is API server. Now the question is, what is API server? What is API server? Remember, it's a front end. It's a front end to the control plane. That means there must be something here So which make this very unique. And what is that? So guys, whenever I want to know about something, I want to learn, I have an approach which I'm going to share with you. Probably it will help you as well in the future while working and learning with something else. Now it says here, guys, this is the master, okay, and it has a 4-component API server and one more, 4 component. Now I'm talking about this one, okay. Now API server, let's only draw our API server. This is the API server. So now here we have API server. So now here we have 2 words, API and server. So what is the meaning of server? You know that. Server, the meaning of server is you have a multiple API. Yes. So 1 API, 2 API, 3 API, 4 API, 5. So what is API? It's one feature, guys. So hundreds of API you have. So basically, when I'm thinking about API server, mind it here, you have hundreds of features which you can consume, which you can ask from API server. Hundreds of features you have. Which are those features? We will slowly learn. But right now, I got to know master has a 4 component. One of the component, which is important one, front end to the control plane, is called API server. API server get exposed at the API, REST API, consume JSON. API server means that has a multiple API. Is that clear, guys, for so far? Any questions? Any questions? Now guys, second component we have is a cluster store. Now a question is, what is a cluster store? So guys, anything we want to store a data in any format, you need some sort of storage application, right? Storage application such as you have a hard disk for storing the files. You have a database for storing the structured data. Nowadays we have NoSQL also, not structured data. So now here in the API server, everything we receive through the JSON. So that is in a form of key and value, right? So we need someone to store the data of the key and value of what? Of the infrastructure, of the cluster. Or someone is giving some information to me, API server, then it should be storing it. So look at the image here very carefully. API server is the front end, but at the same time, it receives the data and stores somewhere. And that component, we call it cluster store. We also call it etcd. So guys, this is the storage. This is a persistent storage where it gets stored the information of the cluster state and configuration file. Now, what tool is using for the storage? So guys, this is a tool which is being used for is etcd. It's open source, distributed, consistent, watchable keys and values. You can store it. So it's a free open source available. So yes, anything in Kubernetes, the storage means etcd. That's the second component of the mastered server. And one more thing important is this is the source of truth for the cluster. Means if you have in the cluster store, you have in the cluster as well. If you don't have in the cluster store, you have no, that thing is not exist in the whole world. Simple. So API server is the first component, front end. Cluster store is the second component.
Please enroll our general membership for $399 plan to get access of all the parts.
Along with that, you can access our other tutorials such as Docker, Ansible, Jenkins, Terraform, Splunk, AWS, Azure, and various other DevOps related premium tutorials with our channel membership. If you would have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. To get our channel membership, click onto the join button, select the $399 plan and grow your skills immensely. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.